Good afternoon. My name is Antoine. I'm working at FUGRO since 7 years now, almost. I'm excited to talk to you today about a topic that is fundamental to quality and efficiency in almost every industry, which is dimensional control. First of all, as a quick introduction, I'll give a small presentation of the FUGRO company. So we are the world-leading geodata specialist offering solution in 3 key markets: water, energy, and infrastructure. And all that across the full life cycle of a project. So from planning, feasibility, conceptual design, construction, operation and maintenances, and finally decommissioning. FUGRO provides a full portfolio of solutions, such as for the most well-known geophysical and geotechnical survey, but also metocean, geohazards, geodynamics, geochemicals, geospatial, and also global positioning. Regarding offshore wind farm project lifecycle, like other projects, FUGRO provides full range of geodata from marine geophysical survey, power cable design, marine geotechnical site investigation, etc., etc. And you can see here where is dimensional control in the lifecycle. So starting in the middle of design through installation, and it can also go a little bit through operation. Here is a list of our major clients regarding dimensional control in offshore wind farms. So smulders for Provence Grand Large, PGL and EFGL project. And Ponticile Matière for EOLMed, where 3 pilot projects where we were experts in dimension control full-time during the project. EDF, Renewable, IRIMA, Equinor, and IPM for a flange survey, but we'll go more into details about that later on. So the dimensional control will be leading to 4 steps. First, what is dimensional control? Why is dimensional control? Third part, how is it done? And then what are the benefits? So, sorry. So what is dimensional control? Today, almost all industrial assets are built in a modular way. That means that with Lego brick example, every bricks are fabricated in different places, and they are also assembled in other places where or near the asset is needed. This leads to have an efficient and cost-effective project for developers, but every element needs to be carefully built. Because even for the best constructors, building simply a structure, sometimes it does not fit. Here we are talking about Lego. But what about real project? What are the risks for our client if dimensional control is not properly done at each stage of a project? I think you can easily imagine the pain and the cost for our clients if structures do not fit together. So finally, what's dimensional control? At its core, dimensional control is the process of ensuring the manufactured part and assemblies conform to the specified size, shapes, and features. The use of dimensional control can be summarized by when things have to be aligned, vertical, circular, and planar. This to be compliant with theoretical drawings and to make sure that structure that needs to fit together will do in good time. Think of it as the guardian of geometry. On overall, dimensional control is a combination of precise 3D measurements, mathematical modeling, and geometrical analysis and comparison. But also, we'll go more into details about that later on. Little aside, just a quick clarification. Dimensional control is modular construction, is a bit different from the term metrology. where metrology is typically known and understood as included in the production line. While metrology controls the dimension during the production, for us, dimensional control experts, it's about checking dimensions with the same accuracy for blocks that are built outside of the main production line or after the factory team is done with their part. It's truly a field logic or a real on-site perspective. So next, why is dimensional control so important? First of all, it's important to define the term tolerance in the construction sector. During the design phase, the developers, the engineers, they define the precise dimension of an acceptable variation. And this helps to tell us how perfectly shaped structures and assets needs to be. The tolerance defines an allowable deviation the structures can be from theoretical drawings, and this gives us a window of acceptability. We can find several consequences regarding the lack of dimensional control within the modular construction industry. First one, as we saw in the introduction, fit and assembly. Part of the structure do not fit together, but also functionality and performances. If part of the structure are not properly manufactured, it will for sure reduce the efficiency of the final construction by decreasing the lifetime of it, or even generate a potential failure at early stage. The cost, lots of money involved. Every year, it's billions of euros lost worldwide due to scrap, reworks, warranty claim, directly attributable to dimensional mistakes. Dimensional control is here to remove suspicions. Other points, when production does not meet expectation, it does not help to give a good opinion of your reputation. It's not just about making a perfect part, it's about making a functional part that is integrating seamlessly and reliably into a larger system. On overall, dimensional control is ensuring clients' responsibility by de-risking. This is by far the most important slide of the presentation. So, how is dimensional control performed? As said before, dimensional control is a combination of precise measurement with three-dimensional mathematical modeling in order to analyze the item surveyed and compare it with another object, or with design drawings. Concerning precision measurement, we rely on a set of fast, reliable, and accurate equipment. Laser tracker, total station, laser scanner, photogrammetry, but also tools like easy laser, calipers, or digital levels. I won't go into details about these technologies or these equipments, but the only thing you need to know is that for dimensional control, we are talking about millimeter or even sub-millimetric accuracy measurements. Even if this instrument looks traditional, look like traditional land survey equipment, for most of them, they are far more precise, no need to say far more costly. And also, we develop specific protocols of data acquisition and data processing to achieve high accuracy. Regarding processing, this is also a fundamental element of success and guarantee of quality. 3D computation and transformation are the key. An acquisition allows the generation of advanced 3D models which can be added in their design software or in the deformation model. But also, like in the bottom right corner of this slide, to standardized 2D drawings used by construction experts. So, regarding the process of a project lifecycle, when and where. First, fabrication yard. Here, we focus on manufacturing inspections. Dimensional control focus on blocks that compose the structure, so block must be compliant to drawing. Here, block 1 is compared to design 1. For offshore wind farm, it could be part of the floaters, such as braces, plates, etc., or for part of the turbine, such as blade, part of the towers, but also transition piece, flange, connecting the floaters and the turbine. And at this stage, one of FUGRO best value is a strong inter-yard communication. This helps to ensure the client to receive all the information they need to adjust plan if necessary, such as when part does not fit together or are outside the tolerances. On the assembly yard, here we focus on interfaces. So please note that this stage, this is also something that we can do prior to assembly yard by doing virtual fit, for example, during the fabrication yard part, and also during the assembly. At this stage, so we control blocks position, which can be performed by classical survey or even real-time positioning. It goes by pre-weld survey, also post-weld survey. Here, block 1 is linked to block 2. Finally, final inspection, or as built, it happened on the assembly yard, usually, before shipping. We control here the final assembly of the whole structure, and we make sure that everything is matching tolerances. But this is not the only time there is a need of dimensional control. Indeed, sometime in projects, it can happen that developers, constructors, or even insurance, they face a doubt. So dimensional control at this time, on the fourth time, it can be deployed for punctual inspection at any steps as a forensic analysis. So this can be either onshore, offshore, on land, or even subsea. And finally, we deploy dimensional control as external. This to survey, external survey, to provide comparison verifications such as a global expertise in order to check the dimensional control work done by another entity to reassure the client. So finally, what are the benefits? Benefits of the dimensional control. The first one is no surprise. Dimensional control ensures that design faces the design tolerances, and we make sure that they are achieved. Dimensional control produces cost, resource, and time savings by having seamless fit of the modules of the blocks once their first presentation. No rework during assembly, so quicker installation. And it also helps to improve safety by having an efficient production. Also, it improves quality and reliability, product quality. And last but not least, client satisfaction and reputation. So this is the benefit of dimensional control. But what are the benefits of choosing FUGRO? As said before, we are present in the full life cycle of offshore wind farm projects. So actions to make and scope are mutualized, and this leads to have a single point of contact. We are also a worldwide team of FUGRO surveyors and experts specialized in dimensional control survey, with offices in 57 countries in the world, and including 9 main hubs. This ties in with the point mentioned earlier. Our global presence leads to the strong inter-yard communication. We also have a wide experience, able to adapt survey strategy to particular field conditions, especially when structures are super big, high, upside down, or dilating regarding the temperature matter of the metal and the concrete, which is a matter to include in the calculation. Here's a quote from the PGL Constructor Management, where a project where we were full-time dimensional control experts in the construction of the floater from the beginning to the monitoring of the structure during the turbine assembly. Before we finish, we can set up a brief part about some lessons learned and recommendation taken from our experience, our offshore wind farm experience. For all projects we have been working on, it has always started with the question, what are the tolerances of the project? What do we have to reach? Every time answer where we have to reach millimetric accuracy. Okay? As I said before, in dimensional control, we can reach sub-millimetric accuracy, but take belt and braces approach as a cost. And this costs money, but it costs also time. Maybe as a recommendation of this lesson learned, it could be a good idea to have further discussions with developers, engineers, regarding this topic, as we will face challenges, challenging construction in the near future, with more and more construction, more and more structure to build in production line. But this point leads to the first recommendation. Our first recommendation would be to include dimensional control process earlier in the discussion. We would firmly suggest and advise to include this process earlier in the discussion, for example, at early stage, maybe during the design phase, to discuss about the scope, to discuss about the time schedule to perform dimensional control, because it takes time, but we can reduce it, of course. But also how we could manage the yard organization in order to be the most efficient possible. As I said, in the near future, we are going to create offshore wind farm industry 4.0, which will be able to provide not only 3 floaters in 2 years, but more something like 4 per month. So we should think of including dimensional control into the production line in order to ensure a good productivity. Another recommendation is more about more technical one. It would concern the punctual survey, such as forensic analysis or even maintenances. It would be good to add a permanent painted target and waterproof target on the structure, so it would ease a lot the survey once, even if it's offshore or once it's loaded out. Finally, to conclude, we can say that it's quite difficult to dress a value proposition about dimensional control and to quantify the benefits of it when talking about money, because it really depends on project. From a cost perspective, dimensional control is a very small percentage of the total project price. From our experience in offshore wind farm, it's between 0.1% and 0.3%. Which looks ridiculous to comparison to the risk of having a standby day of offshore activity. However, that's true that it is a recurrent point that we are having as a discussion with our client. Here is a quick video. Here's a quick video of that recaps our activities of dimensional control on EolMed project.
Offshore wind industry, precision is key. Offshore structures face extreme forces from wind, waves, and currents. For their stability and longevity, ensuring a perfect fit when they are constructed is crucial. FUGRO offers cutting-edge dimensional control services, providing precise measurements and expert analysis for modular construction blocks. From photogrammetry to laser tracker measurements, our precise methods ensure sub-millimeter accuracy. We measure, analyze, and report to ensure you always get the most reliable results. Our expertise spans the globe, delivering first-rate dimensional control services for projects worldwide. From surveying blocks at manufacture sites to their assembly, FUGRO ensures a perfect control to secure pieces will fit together no matter where in the world your project is. FUGRO's dimensional control, precision, reliability, and efficiency for the modular construction industry.
Thank you everyone for your attention. The presentation is now over. I'm happy to take any question you may have, now or later. And we are at stand B26.